Hey, Algebra 1, let's go over the answer key for our review packet here for the test. Now, there are some modifications to these that kind of prep you a little bit better for the test. You know, not to spoon feed you like the stuff that you'll see on the test, but to help prioritize stuff. Definitely 1, 2, 3, you know, and then, you know, 4, and 5. Definitely these are core problems that you'll see ones that are just like that. When we get to like one like this one, number 6, I'm gonna hold off on going over this because it's not necessarily the style of how the questions that like asked on the test, and I want to help you with that. The one that is closest to this one on the test is one where I'm going to give you 4 graphs. And so like I'm actually going to set this one up like we would have on the test: 4 graphs. And on the test I give you the line, but 2 of the lines are solid and 2 of the lines are dashed. All right, so I give that to you. And then the other thing that I give you is I also give you that, you know, 2 of these, one of them that's solid is shaded above, one that's dashed is shaded above, and one that's solid is shaded below, and one that's dashed is shaded below. This now better matches the type of problem that is on the test. It's a multiple choice problem, but we're gonna have to do some work with it. So here's the thing, I'm gonna go through this a little out of order. So I'm gonna jump straight to this one since I'm talking about it. And it says, really it's like which graph, let's call this one A and B and C and D. Which one would represent this graph? So what, I'm gonna zoom in just a little bit. It's like, how do we know? Well, we look at this symbol right here, and that's a less than or equal to symbol. I'm focusing on that because it has the equal sign. If it was just like less than, then we would have a dotted line. But because it's less than or equal to, because it has that equal to, it's gonna be a solid line. So a solid line is what we want. Now, what that means is that we can rule out, we know that it's not gonna be C with the dashed line, it's not gonna be D with the dashed line, it's gonna be one of these. On your test, I actually want you to eliminate some just like that. Now, how do we know whether this one or this one has the correct shading for that? Well, that's the next step of doing a test point. So test a point. Now, just like we said in class, what's the nicest point that we could test in here? The origin. So test the origin and test the coordinate 0, 0, as long as the line doesn't go through that. And this line is below that, doesn't go through that, so we can test 0, 0. Take that x value, that y value, and put it in here. So let's rewrite this as -2, but instead of x, it's times 0. 4, so plus 4 times the y, but the y is also 0. And then is that less than or equal to -12? We test it, so we're testing it. -2 times 0 is 0. 4 plus times 0 is 0, and we get 0 plus 0 is 0. And is 0 less than or equal to -12? Honestly, think about that. Is 0 less than -12? Well, -12 is, no, that's less than 0, so this is false. Now, because that's false, that means that the point 0, 0 is not a solution. It's not a solution, just like this one. 0, 0 is not in the shaded area. Good, so it's gotta be this one. The shading has to be in the opposite side. This graph is the graph that represents this set of solutions, not A. Okay, so we ruled out A because A would have 0, 0 in there. If the symbol is flipped, then that would be true. Okay, so that's going over one of the problems. Another thing that I wanna say is that in class today, remember in the study guide, I made up a problem that was like the blueberry plants? Number 9, 10, and 11. These are all great practice problems. I encourage you to look at the answer key and use these as practice problems. But the problem on the test, the blueberry problem, that is in the study guide. It's a slide that's posted in the study guide. I put it as the top slide. That blueberry problem is a better match. And what do I mean by that? It's a better match for the problem that's on the test. The problem that's on the test isn't talking about concerts and stuff like that. And it's not talking about seats and tickets and stuff like that. The problem on the test is talking about a garden that has a certain amount of area. And in class, I use my garden as an example. So anyway, that's the one that's gonna match that. I'm gonna do a separate video about that garden problem. And let's go, man, I'm going out of order here. So fine, let's do number 8. When I look at this one, we're not gonna focus on graphing it. We're just gonna focus on checking, is this a solution? Is this a solution? Is this a solution? So we have 2 times a number plus another number. The number y is less than 8. I'm just copying this down here, and now I can use pencil. I'm gonna zoom in a bit. Now I can use pencil, and when I have an x value and a y value, you can put the x value here and the y value here in place of those variables, and I simplify this. What's 2 times 0? 0. Plus 0? 0. Is 0 less than or equal to 8? Is that true? Yes. 0 is smaller than 8, so this is a solution. All right. Now I change my numbers, okay? So 5 and -2. Put a 5 in where I see the x. 5, -2. Okay. What's 2 times 5? That's 10. 10 minus 2 is 8. Is 8 less than 8? No, it's not less than 8. That's not a solution. However, 8 is equal to 8, and so if this had an equal to sign, it would be a solution. If it had that little line underneath it. What this means is that 8 is on the boundary line. So, or this 5 and -2. The point 5, -2 is a point that is on the boundary line somewhere. Okay, anyway. So we just keep doing this with each pair of numbers. Now a -1 for x and a 4 for y. You see how this is kind of handy to set up as a way of me, instead of rewriting everything, I just plug these in. I encourage you to do that. Write part of it in pen and part of it in pencil. Anyway, what's 2 times -1? That's a -2. -2 plus 4 would be just 2. Is 2 less than 8? Yes. Okay. And we could try the next one. -3 and 5. -3, 5. 2 times -3 is -6. -6 plus a -5 is -11. Yep. -11 is less than 8. That's a solution. Okay, and the last one, 7 and 7. So 2 times 7 is 14, and if I add another 7 to that, I get 21. Is 21 less than 8? No, that's not true. 21's bigger than 8, so that's not a solution. Okay, so you're gonna have problems like that. Now we'll go back to the front page that has a good core amount of, the core types of problems of solving equations. Okay, so I'm going to zoom in, and I'm going to try to make my work fit in this little tiny space. On the test, I give you way more space than this to solve these. All right, we want to solve this and get the x by itself, but there's x's on both sides. The first thing I would do would be to distribute that 4 and do 4 times x to get 4x and 4 times 2 to get 8. A lot of students forget to multiply that last number when they distribute, and they'll have a 2 here, and that cascades and creates problems down the road because it's not the right number. Okay, how do I solve this now? Well, I have variables on both sides. It doesn't matter which side, but I want to get rid of some variables on one side so that I end up with a variable on the other side. Now, I could have subtracted 4x's, but I get a -1 on one side. If I subtract 3x from both sides, this goes away, and this just turns into x, which is really nice. Now, if I continue with this, another step at the same time, if I got the x on the side, I could take away 8 and take away 8. What's -1 minus 8? Over here, that's 0, but this would be -9, and that is our solution. X is equal to -9. We continue down here, another problem of how do we solve this? Well, first thing I want to do is take the 6x and the 2x and combine it to make it 8x. We can add those together. All right, but I can't add the 11 with it because that's not a like term. But what I can do next is I could get the x by itself, not by dividing by 8, not yet, but by taking 11 away from 3. 3 minus 11 is, so let's see, that's 8. 8. Positive 8 is equal to 8. No, -8 is equal to 8x. And now my last step would be to divide by 8, divide by 8. Okay, and -8 divided by 8, we would get x is equal to -1. Okay, 8 divided by 8 is just the x. And number 3, this has an inequality symbol. So as we solve this, I want to be careful to see, like, am I going to have to flip that symbol or not? All right, so I do want to distribute. I'm going to do that. -4 times 3 is -12m. And what is -4 times a -1? That is a +4. Is less than or equal to 2m minus 24. I'm glad I got a little extra room to work with this because it's going to take some space. Now I have a choice here. I could take away 2m from both sides, all right, to get the m's on this side, but then I'd have a negative, or I could add 12m to the other side, but then the m would be on the wrong side. At the very end, I'd have to flip whatever I get so that the m is on the correct side. I'm going to choose to do the thing that's a little bit harder. I'm going to take away 2m and take away 2m, all right? And why is this a little harder? Because I'm going to have to deal with that negative here. But I want you to see what would happen. So I get 14m, at this, a negative 14m, because negative 12 minus 2 is negative 14. At the same time, I can also subtract 4 and subtract 4. All right, so this symbol, less than or equal to, this turns to 0. Negative 24 minus 4 is negative 28. And now you're going to see why I chose to do this one. It's because I wanted to model what happens if we divide by a negative 14. A negative 14, the symbol switches from less than or equal to greater than or equal to. We get m on one side, and on the other side we get positive 2. That's our solution. Now, if you solved this and you got the m on the other side, and you got that as an answer, just remember that you would have to eventually flip the entire thing around, put the m over here, flip the symbol with it, and put the 2 on the other side. Because I divided by negative 14, the symbol flip happened here, and the variable was able to stay where it was. I think that's it. I think that's it, going over all these problems that are core problems of the study guide, the practice day in class. Also look out for a video on the blueberry problem that's in the study guide. Take care.